Hey guys, today's video is about proximity measures, and finally, it's the last video for proximity measures. I'll talk about cosine similarity, which is a measure used in specific cases. Cosine similarity is used in sparse numeric data, where zero matches are not of interest. Sparse vectors mean vectors with a lot of zeros. You might ask, when are zero matches not interesting? The most popular example is document comparison. We measure how similar two documents are by counting the words within a document and find a way to compare the common words of two documents. The cosine similarity formula is like this. X and Y are the vectors we want to compare. Cosine is actually an angle. Remember what we learned in high school math? Here, we apply the same concept and measure the angle between two vectors. And this angle will be in a range of 0 to 1. So, it's kind of already normalized, so we don't have to do extra normalization like we did in numeric data. One of the advantages of using cosine similarity is that two vectors can have different lengths. If you think about it, the angle is totally unrelated to the length of vectors. Let's look at the formula. The numerator is the dot product of vectors, which is the sum of the products of the corresponding entries of two vectors. The denominator is the Euclidean distance of x and y. If you don't know what Euclidean distance is, please go and check out video 3.2 in my channel, but I'll briefly talk about it now. Euclidean distance is also the length of a vector. Say we have vector 2, 2, which means the vector ends in the position 2, 2. In fact, the length of this vector is the distance between the origin and 2, 2. Euclidean distance measures the shortest distance between 2 points, and we do want to measure the shortest distance between the points 0, 0 and 2, 2. Now you see why Euclidean distance is also the length of a vector. Another thing I want to mention is that the denominator here is kind of like the normalization process. We divided the dot product by the length of two vectors, so it's fine for vectors to be of different sizes. After all, we are gonna to divide the dot product by the vector sizes and remove the effect of them. As we said before, cosine similarity is often used to measure similarity between documents. And again, it's perfectly fine for documents to be of different sizes. Say, we have documents A and B, and the attributes are the word counts, so the word apple doesn't appear in document A at all, but it appears in document B 3 times. We can directly plug in our formula. We first calculate the dot product of two vectors, which is really straightforward. Remember how we said before that zero matches are not interesting? In fact, a single zero is also not interesting. For the attribute apple, document A has 0 counts, and the product of that attribute turns out to be 0, which doesn't contribute to the similarity. Then, we deal with the denominator. We calculate the Euclidean distance of document A and B. Afterwards, we just put the numbers in the formula. The cosine similarity between documents is around 0.695. Correspondingly, the dissimilarity between them is 1 minus 0.695, which is 0.305. So, that's the basic idea of cosine similarity. It's a short video, but this concept is pretty useful in some cases. Thank you for watching my video and see you next time.